All right, the other big topic we're going to handle in the Trig Identities integration chapter, chapter 6.3, is correlating sines with sines, sines with cosines, cosines with cosines at various frequencies. We might have a signal coming in from a radio or over a microphone or something, and we want to say how related is that to another signal, or how related is that to kind of a pure signal like a sine or cosine. So that's an idea related to Fourier series, which we'll talk about later. It's also interesting how related it is to other things in the math universe. If you've seen correlation in statistics, you might have seen the formula involves this. It has other stuff, but it's basically saying if we have a data set X and a data set that's paired with it, item by item, called Y, the correlation formula can involve this: multiply each pair and then add them all up, like that sum. In matrix algebra, linear algebra, you might have seen the dot product of two vectors. You take the first one from the first vector and the first one from the second vector, multiply them, second one, multiply them, do all that, and then add that all up. So that actually gives the hint that in matrix algebra, this dot product is related to a correlation, which is really interesting. Excel even has a function to do this called sum product. You can see why, which we use a bunch in some of my other classes. We're not going to use it here. Let's take this idea of multiply things together and add them up and do an integral with it. So this is kind of saying, what's the correlation of sine 3x with sine 1x? I mean, we would have to do some other things to really do a correlation, but it's the start of that idea. So we can't just use U substitution here or integration by parts. They won't work. So if we go take a look at page 298, we'll see some helpful trig identities. Let's do that. So here we are on page 298 of the PDF file. Let's see, where's our page number? There it is. And we'll go up and see these sum to product formulas, or product to sum. And we have this one, right? We have the multiplication of two sines. So let's go write that on our paper. All right, so I've got the trig identity there. What is it for this situation? What are m and n? Well, we apparently wrote it right underneath what we need, right? M would be 3 and n would be 1. So we've got sine of 3x times sine of 1x equals 1/2 cosine of 3 minus 1 minus cosine of 3 plus 1 x. So notice I'm not actually doing the integral at this point. I'm just saying, what is this expression kind of inside the integral? And now before I go and do the integral, I should check that I did my work correctly, because I don't want to do a bunch of integration work if I got something wrong here, right? So what I would do is go type in this formula and type in that formula and make sure they're the same. Let's go do that. All right, here I've got the original integrand, sine 3x times sine 1x. I have my trig identity version of it here, and let's see if it exactly overlaps. That's looking good. And then I even simplified this 3 minus 1 to 2, this 3 plus 1 to 4, just because it's a lot easier to write. And let's check that we got that one correct too. Yep, that's looking good. All right, let's go back and do the integration. All right, so the integral of this formula I started with would be the integral of this formula we got from a trig identity, simplified here with the 2 and the 4. And then how do we take the integral of that? Well, the 1/2 is a constant multiplier. We just copy it there. Integral of cosine is negative sine at the same frequency, but then divide by the frequency multiplier, minus, and then the integral of cosine is negative sine at the same frequency, but then divide by the frequency multiplier. That's our favorite shortcut. And then that plus c. So are we pretty much done? What is there to do? We could say that capital F of x equals this whole thing, and go graph capital F of x and graph lowercase f, and make sure that f prime of x exactly overlaps little f, right? Which was sine 3x sine 1x. Wait, I got something wrong, didn't I? Integral of cosine is positive sine. So we should put a plus there and a plus there. Phew, that must have saved a lot of trouble. All right, in the next video, we'll talk about this as a definite integral.